Bismillahirrahmanirrahim. Assalamu alaikum, my dear student. I'm your instructor, Engineer Hassan Khan, Assistant Professor, Civil Engineering Department, Sood, Peshawar. And today, this is the fourth lecture of Engineering Hydrology. In this lecture, we will discuss about precipitation. We will know about different forms of precipitation, how precipitation form in the precipitation formation process, and we will also discuss different types of precipitation. This is actually, as we discuss in the first chapter, in the first lecture of this subject, that hydrology is totally understanding the hydrological cycle. So in the hydrological cycle, there are various terms, various processes, one of which is precipitation. So in this subject, beyond this, up to the midterm lectures, inshallah, we will discuss one of the main component of hydrological cycle, that is precipitation. So in this first lecture, we will only discuss precipitation, its different forms, how precipitation formation occur, and what are the different types of precipitation. So let's start. First of all, what is precipitation? What do you know by precipitation? The term precipitation is used in hydrology is meant for all forms of moisture emanating from the clouds. In other words, all form of water like rain, snow, hail, and sleet derived from atmospheric vapors falling to the ground is known as precipitation. As we already seen, that floods and droughts are directly related to the occurrence of precipitation. If in a region there are various precipitation, there is heavy precipitation or heavy rainfall or heavy hail or snowfall, so what occurs? In the downstream areas, floods occur. And conversely, if there are no rain in an area, no precipitation in an area, then it is time for a drought. So the floods and drought are directly related to the occurrence of precipitation. Now, in civil engineering, various projects such as water resources management, water supply scheme, irrigation scheme, hydrologic data for design of hydraulic structure, and environmental effects of water resources development projects are related to precipitation in one or the other way. So it is very, very important for a civil engineer to know various aspects of precipitation. That is why we have taken this lecture, precipitation. Now, there are different forms of precipitation, of which few we will discuss in this lecture. The number one is drizzle. Forms or state of precipitation. It is to be very, very clear. Forms mean state, condition of the water, in which condition and which state the precipitation occurs. And type we will use for another concept. So drizzle are also called mist. These are actually the smallest minute particle of water at start of rain. Whenever a rain starts, before the rain, if you held your open hand in the air, you will feel very, very minute particle of water at the start of rain. These minute particles are known as drizzle or mist. The diameter of drizzle usually, the diameter of these particles usually between 0.1 mm to 0.5 millimeter. If it increases 0.5 millimeter, then it is called as rain. But below 0.5 millimeter, it is known as drizzle. Intensity or rate of fall of drizzle. Usually the intensity of drizzle is less than 1 millimeter per hour. A rate of fall of drizzle is less than 1 millimeter per hour. Their rate of setting is so slow that we cannot even feel them. Therefore, they cannot flow over the surface but usually evaporate. The second form of precipitation is called as rain. Rain refers to the amount of liquid precipitation. This is the most important form of precipitation is the rain. The raindrop's diameter is larger than 0.5 millimeter because up to 0.5 millimeter it is drizzle and is less than 6.25 millimeter, and the maximum diameter, the maximum drop diameter of the rainfall is 6.25 millimeter. Rain has three types. Number one is light rain, moderate rain, heavy rain, and these types are according to the intensity or rate of rainfall. Light rainfall means whose intensity is up to the 2.5 millimeter per hour. Mean the intensity of rain is greater than 1 millimeter per hour, because up to the 1 millimeter per hour intensity is for drizzle, and it is up to the 2.5 millimeter per hour. So from 1 millimeter to 2.5 millimeter per hour intensity rain is known as light rain. And if the intensity increases from 2.8 and up to 7.6 millimeter per hour, then the rain is named as moderate rain. And if the intensity is more than 7.6 millimeter per hour, then it is called as heavy rainfall. You know, rain can produce flow over the ground and can infiltrate and percolate. All these terms are already discussed in the first lecture. Both the duration as well as rate of rainfall are important. If the rainfall per unit time is greater than the rate of infiltration, the rain water can flow over the surface of earth. You know, if the rain per unit time, if the rainfall rate is more than the rate of infiltration, mean the water coming from the atmosphere, coming from the clouds are with more speeds, and the water infiltrating down to the earth is with a less speed. So there will be an amount of water on the surface of the ground, and that amount of water will start flow over the surface of earth. Next type is glaze. Glaze is actually the ice coating which is very clear and smooth. It is only the ice coating, thin coating formed on exposed surfaces by freezing supercooled drizzle or raindrops. Its specific gravity can be as high as 0.8 to 0.9. Okay, glaze is actually if a raindrop or a drizzle drop sets on any object, and if the temperature of that object decreases, drops down the 0 degrees centigrade, so a clear and smooth layer of ice form on the top surface of the drop, and this layer is now known as glaze because it glazes. As you can see, its specific gravity is 0.8 to 0.9, very close to the liquid water. What does it mean? It means that the specific gravity is close to the liquid water. It means that only a thin layer above the drop is converted to the ice, while below this thin layer all the drop is completely liquid. Only a top surface layer is converted to solid ice. Sleet is another form of precipitation. Sleet is actually frozen raindrops cooled to the ice stage while falling through air at sub-freezing temperature. This is a very interesting thing. This is not actually snow, nor it is hail. It is actually at the start, at the formation, it is rain. Mean from the clouds, when it start coming down, it is rain. But in the way an air or a layer of air comes whose temperature is below 0 degrees centigrade. So when these drops enter to that freezing air, these drops also convert to the ice stage, iced condition, to the solid form. So now when they fall on the ground, they are just like hail, but this is not hail. Hail particles are very large and sleet particles are small. And the specific gravity, if you see, the specific gravity of the sleet particle is as low as 0.2 to 0.3. What does it mean, 0.2 to 0.3? You know, when a liquid water converts to solid form, its specific gravity becomes lesser, become in 0.1, 0.2, 0.3. Now if we compress a solid, its specific gravity will increases. So this is very less specific gravity, 0.2 to 0.3. What does it mean? That this is the particle or the drops of sleet are actually not compressed. But if you see the specific gravity of hail, it will be close to the specific gravity of water. What does it mean, specific gravity of water? The specific gravity of water is considered to be 1. So if a specific gravity is closer to 1, it means that it is as compressed, as heavier as water, as denser as water. Snow, another form of precipitation is snow. Snow is precipitation in the form of ice crystals resulting from sublimation. Sublimation is actually change of water vapor directly to ice stage. Snow is already you know, and you may have seen in the northern areas of Pakistan. The snow diameter is up to 100 millimeter. It is actually not one drop, but the snowfall occurs in the form of snowflakes, and the snowflakes diameter is up to 100 millimeter. The specific gravity of snow is 0.1 on average, least specific gravity. What is a snowflake? Snowflake is made up of a number of ice crystals bonded together. Snow crystals bonded together coming down from the clouds towards the earth is known as snowflake. Hail is the type of precipitation in the form of balls or lumps of ice, and these are very compressed form. That is why the specific gravity of hail, if you see, is 0.8, mean that these are the compressed ice. Its diameter is from 5 millimeter to more than 1 to 5 millimeter. 1 to 5 millimeter. One of the largest hailstone of record in USA fall at Coffee Valley came September 3, 1970 of 44 millimeter in circumference and whose weight was 0.766 kg. This is one of the recorded hailstone. Circumference is 44 millimeter and weight is 0.766 kg. Now here is a very good video of different forms of precipitation in which you can see and hear the sound of different forms of precipitation very clearly. So precipitation. So the first form is the rain. This is rain. You have seen many times in your homes. Form number 2 is the sleet. Try to hear the sound of sleet and then the sound of hail. Size of particle. Now hail. The last one is snow. Beautiful snowfall in a hilly area. Okay, next is factor influencing precipitation formation. Actually, this is you can also say the precipitation formation process. By these factors, we are actually describing the precipitation formation process. So there are 3 factors which influence the formation of precipitation. Number 1 is a lifting mechanism to produce cooling of the air. Number 2 is a mechanism to produce condensation of water vapors and formation of cloud droplets. And number last step is a mechanism to produce growth of cloud droplets to size capable of falling to the ground against the lifting force of air. So if we see what is the process of formation of precipitation. The process of formation of precipitation, actually if we start from the very beginning, so when solar energy comes on any water body, the water particle or the water molecules convert it into the vapor form, and these vapors start rising in the air, because these vapors are actually light and having higher energy, so these starting moving towards the higher altitudes. So this first thing is the lifting mechanism. Why these particles are going upward? This is actually by lapse rate or by any other phenomena, as we discuss in lecture number 2. Lapse rate, adiabatic lapse rate, or by front movement, or by cyclone movement, or by convection process. all these processes can ascend an air having moisture. So we will need a lifting mechanism to cool this moisture laden air. The second step is condensation of water vapors. Now, with rising of this air, the vapors inside this air becomes cools. And with cooling, with rising it cools, and when the air reaches up to a specific height, specific altitudes, then the temperature of this air becomes to the dew point temperature. Dew point temperature we have already discussed in second lecture. Dew point temperature is a temperature in which the moisture present in this air are able to convert into the liquid form. So when the temperature reaches to the dew point, then cloud droplets form, minute particle of water or solid ice form. So the next step after formation of solid, this is known as condensation. After condensation, still precipitation not start. What is the next step? The next step, these particles are of very small sizes, and the lifting pressure of the air is more than the weight pressure of these particles. So the weight of these particles is lower than the lifting pressure. Therefore, these particles will not come down on the earth. So that means precipitation will not start. So a next step number 3 is required for the growth of these droplets of these particles to any size which is capable of falling to the ground against the lifting force of the air. So let's discuss these steps one by one. So the first step is the mechanism of cooling. How the cooling process occurs. When air ascends from near the surface to the upper levels in the atmosphere, it cools. How it cools? This is the only mechanism capable of producing the degree and rate of cooling needed to account for heavy rainfall. As you know, when an air is given heat, it has gained some energy, and due to this energy, this air will move upward, will rise upward, will ascend to the upper level. Upper level are higher stages. So when these air or when these vapors going upward, with this motion they loses their energy, and so they becomes cool, or with the lapse rate they become cool. So cooling lowers the capacity of a given volume of air to hold certain amount of water vapors. As a result, supersaturation occurs, and the excess moisture oversaturation condenses through the cooling process. You know, the air, if you imagine the air molecules, so when air temperature is more, as we have already studied in FSC, the Charles law, the volume of air is inversely proportional to the temperature of the air. If we increases the temperature of any air, the volume will increase. Volume means the space between two air molecules will increase. And if we decrease the temperature of any air parcel, the space between the air molecule will decrease. The air molecule will come close to each other. So when they come close to each other, then the space space for the vapor's molecule is lower. So that is why with cooling the capacity of the vapor holding capacity of the air become lesser, and with further cooling it is supersaturated, and then the vapor inside the air becomes condensed. So this is known as mechanism of cooling. The next step is condensation process. Step number 2 is condensation. Now in the first step they rises up to a certain level. So at this level now the vapors are able to convert into the liquid form, or we can say to condense. But these vapor will only condense if there are enough hygroscopic nuclei, because the vapor condenses on sitting on hygroscopic nuclei. What is hygroscopic nuclei? Hygroscopic nuclei is actually any particle, any small particle having an affinity for water, any particle having an affinity or love or want to get water. So these particles are already available in the clouds. So when the vapors are able to convert or to condense, so these vapors set down on these hygroscopic nuclei, hygroscopic particle, and with setting they are converted into the liquid form. So this is condensation. The source of these condensation nuclei or hygroscopic particle are the sea salt, products of combustion of certain sulfurous in nitrous acid and carbon dioxide. There is always sufficient nuclei present in the atmosphere. The last step of precipitation formation is the growth of droplet. So now the vapor or condenses are already condensed into the liquid or let's suppose solid form, but still there is no precipitation. So the third step is also a must required, that is the growth of droplet, because now the particles are very small and the gravity on these particles is not enough to cancel the upward pressure of the air. So the growth of droplet is required if the liquid water present in the cloud is to reach the ground. So for the growth of droplet there are two very effective processes. Number one is coalescence and number second is coexistence of ice crystals and water droplets. Coalescence of droplets through collision due to difference in speed of motion between larger and smaller droplets. Now in the clouds we have these particles. This is actually for the rainfall process. Coalescence is actually for the rainfall process, the liquid precipitation, and coexistence of ice crystal and water droplets is actually for the snowfall process. So in the coalescence, now this is only let's suppose one liquid droplet, you can see in the figure. Now with this droplet is going downward or going to any side, so there are other liquid droplets, other small drops of liquid which they will collide. When this particle will collide with the other particle will also join with this particle, and finally the size of this particle will increase. And when the size of the particle is heavier enough that the gravity of this particle can cancel the upward pressure of the air, then this particle will come down on the earth in the form of rainfall, raindrop. And this process is known as coalescence. Coalescence is actually just like collision, but just the only difference is the collision word is used when there are two solid particles, and coalescence word is used when two liquid particles. The next coexistence effect generally happens and the temperature range from 10 degree Fahrenheit to 20 degree Fahrenheit. Now this is the temperature of the cloud. If the temperature of the cloud is 10 degree Fahrenheit to 20 degree Fahrenheit, this is actually a freezing temperature. So at this temperature in the clouds there will be two types of material. Liquid water, liquid droplets will be present, and ice crystals will be present. Now if in a layer of clouds there is a mixture of water droplets and ice crystals, the saturation vapor pressure over ice is lower than that over water. Saturation vapor pressure you can assume as a pressure which compels these vapors to remove from the body of the air. This is known as saturation vapor pressure. So this saturation vapor pressure is more on the water and less on the ice. In other words, the ice will convert the water will convert more easily than the ice to the vapor form. So this leads to the evaporation of water drops. So that is why the water present in that layer will evaporates, and these vapors then strike with the solid ice, so condenses on the ice crystal. Do you understand? This leads to the evaporation of water drops and condensation of much of this water on ice crystals, causing their growth and ultimate fall through the clouds. And this effect is known as Bergeron's effect. The ice crystal will further grow as they fall and collide with water droplets. Okay, next is types of precipitation. So the precipitation is often typed according to the factor responsible for lifting of air to higher altitudes, the first step of precipitation formation. So what is the factor for lifting of air? According to that factor, the type of precipitation will be different. So following are the main three types of precipitation based on this classification. Number one is orographic precipitation, are also known as relief precipitation. Number two is convectional precipitation, and number three is cyclonic precipitation, also termed as frontal precipitation. Orograph mean mountain or hill. Convection, convection process. Cyclone, you also know, low pressure area. And front also we have discussed in the second lecture. So the first type is orographic precipitation. In the orographic precipitation, expansion and condensation occurs because moisture-laden air masses are lifted by contact with orograph barriers, with mountain barriers. This type of precipitation is most pronounced on the windward side of mountain range. Generally, heaviest precipitation occurs where favorable orographic effects are present. Orographic precipitation also occurs in the inland areas where mountain ranges rise above the surrounding areas in the path of the moisture-laden air masses. You can see in this picture, this is, let's suppose, an ocean or any water body. Now from this ocean, evaporation occurs, and this vapor rises upward, and since the wind direction is this one, so due to this prevailing wind, the vapors will go to this side, and after hitting with the mountain, the vapor will rises upward, and with this rise, the vapor's temperature decreases, and when the temperature reaches to dew point, these vapors converge to liquid form, and then after completion of all the three processes required for precipitation start on this side of the mountain. This type of precipitation is known as orographic precipitation. The next one is convectional precipitation. You know what is convection? One is conduction and the other is convection. In the liquid and in the gases, the heat is transferred from one point to the another point through the process of convection. If you heated up an area of a liquid or a gas, the molecule will move with the heat, and the molecule in the heat transfer to the other cooled area. This process is known as convection. So the main cause of convectional precipitation is actually thermal convection of the moisture laden air. You know, the air around the earth is moisture laden. It has moisture in it. Now when this earth is heated up by solar radiation, this heated earth air also heated up, and the rising of this warmer lighter air in colder denser surrounding, and then this heated air started rising upward. It is caused because of unequal heating at the surface. A major portion of the solar radiation is utilized in heating the earth. Air which comes in its contact is heated up, and the lapse rate near the surface of the earth increases rapidly. With the passage of time, as the sun gets higher and higher, the lapse rate increases further and air becomes unstable. Vertical currents are then set up which carry heat, and the moisture laden air is packed up from the surface to higher levels. Due to convection, the moist air in the lower levels of the atmosphere rises up to the condensation level, where clouds develop, and with further convection these clouds finally grow, resulting in a thunderstorm. This is the warm moist air rises due to warming from solar heated ground surface. The air rises up to a specific condensation level, condenses, the vapor condenses to the liquid droplets, and then the droplets size increases, the growth of droplets occurs, and finally a heavy precipitation starts, heavy rainfall starts from these clouds. Third type of precipitation is cyclonic or frontal precipitation. Precipitation in plain region is generally cyclonic or frontal precipitation. These precipitation result from the lifting of air converging into a low pressure area or cyclone. Frontal precipitation results from the lifting of warm air on one side over a colder denser air on the other side. If we have colder denser air and warm air, and the boundary between these two air is known as front, is already discussed in lecture 2, and with the interaction of these two different air, one of the air which is warm is always in all situations rises upward. So in one situation, the if warm front movement occurs, then precipitation is known as warm front precipitation, and when the cold air move, then it is known as cold front precipitation. So warm front precipitation is formed in the warm air advancing upward over cold air masses. Cold front precipitation is formed when warm air is forced upward by an advancing mass of cold air. This is, this is cold air and this is warm air. Every time either this one move or this one move. In both situations, the warm air will rise upward. If this one move towards the warm air, so the cold air is actually heavier than the warm air. So that is why the cold air will try to move beneath the warm air, due to which the warm air will rises up. And if the warm air is moving towards the cold air, so the warm air is lighter, that is why it will move above the cold air. So this is actually the rising of the moisten laden air process. Now let's see a video from the YouTube about the precipitation formation process in different types of precipitation.
Stage 1. Warm air causes water to evaporate. This could be the sea, lakes, rivers, or even water from the soil and from vegetation.
Evaporate, that is, the water turns into vapour.
That's right. Stage 2. Warm air rises, carrying the water vapour with it.
Look, stage 3. Rising air cools to dew point.
Dew point. This is the temperature at which air becomes saturated with water vapour.
Now, the air is saturated. That means it cannot hold any more vapour.
Stage 4. Further cooling causes condensation, which means that water vapour turns back into minute droplets of water.
That's how clouds form.
Stage 5, finally. Further cooling produces precipitation.
There you go. Now we know what rain is. But not all types of rain are the same. There are 3 types of rainfall. Relief rainfall, convectional rainfall, and frontal rainfall.
Relief rainfall is caused by air forced to rise over hills or mountains. Convectional rainfall is caused by warm air rising because the ground is warmed up by the sun. In Britain, this would only happen occasionally, but at the equator, because it's so hot, it happens every day.
Frontal rainfall is caused by a warm air mass and a cold air mass meeting, and it occurs in depressions. We'll look at those in a minute.
In this part, we learned that there are 5 stages in the rainmaking process: evaporation, vapour rising, cooling to dew point, condensation, and precipitation.
Okay, that was all for today's lecture. Again, these are my recommended textbooks in reading references. However, I am usually following this highlighted one, Engineering Hydrology 3rd edition by K. Subramania. Thank you very much. Once again, I am Engineer Hassan Khan, and if you have any question, issue, or any problem, you can contact me through my email address hassan.seval@sut.edu.bk. Thank you.